My name is Jennifer. I am 19 years old. I am civil engineering student at the Polytechnic University of Atlautla. And my teacher is Jacqueline Yasmin de la Concha. I am studying the fourth semester in the group 441. And let's start. This is the topic. The topic is volumetric and gravimetric ratios of soils. And this is the problem and the problem size. A wet sand sample of 0.56 cubic feet has a weight of 62.3 pounds. After being baked, it has a weight of 43.5 pounds. The relative specific weight of the soils is equals 2.7. The problem asks you determine the four aspects. The letter A, specific weight of the sample, and letter B, humidity, letter C, dry specific gravity, and letter D, degree of saturation. The gamma with letter M corresponds the specific weight of the sample. Humidity corresponds letter W. Dry specific gravity corresponds gamma with letter D. And degree of saturation corresponds letter G with letter S. And let's start the solution. We must first read and analyze and understand the problem because it's very important, because the problem gives you the date. In basis of the problem, the outline of our science samples is as follows. This is schematics. On the left of the screen, we have the sample volume equals 0.56 cubic feet. The simple volume and the solid volume. The problem size the two phases. One is the liquid phase and the second is the solid phase. This is a representation with the read the problem. And on the right side the screen, we have a sample weight, and we have a weather weight, and we have the solid weight. It corresponding 43.5 pounds, and the simple weight corresponding or is equals 62.3 pounds. Then we write down the dates that the problem he used. For example, 1, 2, 3, 4 dates. He used a sample weight equals 62.3 pounds. The solid weight equals 43.5 pounds. The sample volume equals 0.56 cubic feet. And relative specific weight of solid equals 2.7. And then we must begin to calculate the specific weight, which corresponds to letter A, because as use the problem, we will apply this formula corresponding to the specific weight. The specific weight of sample equals the sample weight divided by sample volume. Then we will proceed to replace the diode according to the problem. The specific weight of sample equals the sample weight equals 62.3 pounds divided by the sample volume corresponding 0.56 cubic feet. In this formula, he use this result, the 111.25 pounds divided by cubic feet. And then we must begin to calculate the humidity, which corresponds to the letter B, the humidity. We will apply this formula. This is the letter B, humidity. And we apply this formula. To the letter B. Aquí está. The formula says the humidity equals water weight divided by solid weight. Solid weight times 100. But after analyzing the formula, we can notice that we don't have a diet. Sorry, don't have a diet corresponding to the weather weight. Then And we get this new formula corresponding to the he used the weather wave. This formula corresponding the picture. This is a picture, because the problem he used more diets. In this case, I have the weather wake, but I have the formula corresponding to the sample weight. Sample weight equals the weather wake plus the solid weight. This is the formula. The sample weight equals the weather weight plus solid weight. Then the free, the date I size. The date is the weather weight because I need for to will proceed to the to replace the diets in the first formula. We will proceed to replace the diet. Weather weight equals sample weight minus solid weight. To replace the diet, weather weight equals 62.3 pounds minus 43.5 pounds. The result is 18.8 pounds. This is diet. I obtain the problem. Okay, the simple weight and the solid weight, and this is the result. But I need to resolve this formula. And now we apply the first formula because I have the two diets. The formula says the humidity equal the weather weight I have the 18.8 pounds divided by the solid weight. The solid weight I have gives you the problem. solid weight is the 43.5 pounds. The 43.5 pounds times 100 equals 43.22%. This is the result. The humidity 43.22%. This is the result. Then we must begin to calculate the tri-specific weight, which corresponds to letter C. Letter C asks use drag-specific gravity corresponding to the letter gamma with G. In this case, we will apply this formula. The tri-specific gravity equals solid weight divided by sample volume. And to replace the diodes in the formula. The tri-specific gravity equals solid weight. Solid weight is a diode I have. Solid weight. Solid weight. This is the diode solid weight. 43.5 pounds. 43.5 pounds divided by sample volume. I have the diode. Corresponding to 0. Corresponding to 0.56 cubic feet. 0.56 cubic feet equals 77.68 pounds divided cubic feet. This is the result. Corresponding to letter C, the dry-specific gravity. Then we begin to calculate the degree saturation with the corresponds to letter D, because the problem asks use degree of saturation corresponding letter G with letter S. We will apply this formula corresponding to the degree of saturation. The degree of saturation is equals the weather volume divided by the void volume then I'm sorry, times 100. But after analyzing the formula, we can notice that we don't to diets because the problem don't ask you. Um, but we have one diet corresponding to the relative specific weight of solid equal or is equal to 0.7 and the apply in this formula. This formula size the relative specific weight equals solid weight divided by solid volume times to the specific weight of sample. But we want to get the volume of solids, so we'll solve for. This is the other formula. The formula size solid volumes or solid volume equals solid weight divided by relative specific weight solid, then times the specific um, the specific weight the weather. We will proceed to replace the diet. The solid volume equals solid weight. The solid weight I have solid weight corresponding or is equals 43.5 pounds. The 43.5 pounds divided by to the relative specific weight of solid. In the diet I have in the problem corresponding 2.7. This is the relative specific solid 2.7 and times specific weight of weather corresponding to the one cubic centimeter, but I need in pounds divided by cubic feet. This is the equivalence of the weight of weather from grams divided by cubic centimeters to pounds divided by cubic feet. This is the equivalence, 63.4 pounds divided b cubic feet. To solve this operation or formula, the result or is equal 0.26 cubic feet. Okay, because I need this diode. But he want to know the volume of voids. Volume of voids. This is the representation. So we must generate a new formula based on the chain. This is our picture. This is the picture. I have used one formula. This is the formula. Is the sample volume equals solid volume plus void volume. It's true because in the picture sample volume it's equal to the solid volume plus void volume. Yes, it says a weather volume, but but the void volume is equals air volume plus weather volume. In this case, or in these problems, it's or I always don't have the air volume, and I have the weather volume. This is this void volume is equals the weather volume, and I don't have the air volume. Okay, this is formula. This is formula corresponds the picture. But we want to obtain the volume of voids, so we will solve for. This is the formula to solve the void volume, because I free. Okay, in this formula I free the void volumes. Void volumes equals sample volumes minus solid volumes, or solid volume. Oh, yes, solid volume is the sample volume minus solid volume. We will proceed to replace the diodes. The void volumes equals the sample volumes. Sample volumes I have sample volumes corresponding to 0.56 cubic feet. This is the depth, 0.56 cubic feet, minus the solid volume. I have depth because after calculate, this is 0.26 cubic feet. This is the formula, or the replace the formula equals 0.3 cubic feet. I have two dates, but I need to replace the first formula in this. I have the two dates. Thus, the weather volume equals 0.3 cubic feet, because they explain in this. But the void volume, because the void volume is equals to the weather volume. In this case, the void volume is equals to the weather volume. Thus, the weather volume is equals 0.3 cubic feet. And now we can substitute the volumes of the first formula. Degree of saturation. Degree of saturation is the depth as use the problem. Okay. I can't resolve the problem because I have the two depths. Degree of saturation. Degree of saturation. This is the first formula. But your recording, I have the first formula to resolve, because to replace the two diodes. The degree of saturation equals weather volume divided by void volume times 100. In this case, replace the diodes. Weather volume I have this is 0.3 cubic feet divided by void volume corresponding, or is equals 0.3 cubic feet times 100. In this case is 1, and to the times 100 it's or is equals 100%. 100%. I size the degree of saturation is equal 100%, because I have the wet and simple. Yes. And this is the 1, 2, 3, the 4 This is the four results. One corresponding to a specific weight of sample. This is one. And this is two corresponding to the humidity. Number three, corresponding to the dry specific gravity. And corresponding to the letter D, the degree of saturation. And finally, it's very important you can't analyze it the problem, because in the occasions I don't have a diet, but I calculator. Bueno, so I calculate the diodes. For example, in this case, I don't have one diode, or in this case, I don't have two diodes, but to apply the other formulas of the they help you. And this is their result. I finish, and thank you for your attention, and bye, see you.